inches. Because we got the longest side as x plus 1 plus 1. And you just add 1 plus 1 there. That's why it becomes x plus 2. And then we got the value of x, which is 14 over 3. So you just add to 14 over 3. You get the LCD of that. LCD is 3. Now you got 14 plus 6. So that is 20 over 3. Got that? Okay, so let's move on to the next problem. Oh, can you please clear the board? Go to the eraser icon and then clear all, erase all. Okay, solve each inequality, graph the solution. So we're given this inequality 3/5 x minus 12 greater than x minus 24. So how are we going to solve this? We need to get rid of the parentheses first, right? So we distribute 3/5 to x minus 12. So that is 3/5 x minus 3/5 times 12 greater than x minus 24. So this is 3/5 x minus 3 times 12 is 36. So 36 over 5 greater than x minus 24. Then we can eliminate the fractions here before grouping like terms. We can multiply both sides by 5. All right? We can multiply both sides by 5. You got this step here. You got this? No questions on this? So if we multiply, we want to get rid of the denominator 5 on the left. So we multiply both sides by 5. Okay? So we multiply that. Each of the terms we multiply by 5. So this is 3/5 x times 5. I will just do like this so it won't be confusing for you. 36 over 5 times 5 greater than x times 5. This one you understand this clearly. 24 times 5. Alright? Then 5 here cancels out. So we're left with 3x minus 5 cancels out here. 36 greater than 5x. What is 24 times 5? That's okay, I'll just write it here somewhere here. Let me delete that. It's alright. Okay, this one is 3x. Can you see this? I'm writing in black. Minus 36 greater than 5x minus 24 times 5 is 120. And then we group like terms. 3x goes with 5x. So we can transpose 5x to the left. That would become negative. So this is 3x minus 5x greater than negative 120. We transpose negative 36 to the right. That will become positive 36. Now you got that. Okay, and then we simplify. We got negative 2x because 3x minus 5x is negative 2x. Negative 120 plus 36. What is that? Okay, negative 84. Then we divide both sides by negative 2. What is 84 divided by negative 2? Yes. Positive 84 divided by negative 2. Negative for a while. Sorry. It's divide. Negative 84 divided by negative. Okay, so since we divide by negative, we change the sign. Instead of greater than, we change to less than. Okay, so that is the value of x. X less than 42. So all of the values less than x equals 42. Can you please clear the board so I can show you? If you're going to graph x less than 42, but if you're going to graph the whole equation, this one, 2 absolute value of 3x. This is the one we're solving, right? I know, 3/5. Should be 3/5 x minus 12 greater than x minus 24. So if this is this one, our coordinate plane, that one is x less than 42, right? So if this is 42, all of the values less than 42, 42 is not included, so it's you can draw a dash line, broken line, so you shade this one, less than 42. This one is better, right? This one. Okay, can you see the black screen? Okay, so the next problem, solve each equation. So 2 absolute value of 3x minus 2 equals 14. So how do we solve this? Okay, so this is an absolute value inequality. Let's get rid of the absolute value first. So we divide both sides by 2. Then we're left with absolute value of 3x minus 2 equals 7, right? Okay, since this is an absolute value inequality, we can split this into two cases. So case 1 is 3x minus 2 equals 7. And then case 2, this is 3x minus 2 equals negative 7. Alright? Then we solve for the value of x. So we add 2 to both sides. Then we have 3x equals 9. Then divide both sides by 3. Then x is equal to 3. Then the other one, the same, we add 2 to both sides. Then this is 3x equals negative 5. Divide 3, x is equal to negative 5 over 3. Okay, so those are the values of x, but we need to check the answers to check for extraneous solutions. Extraneous meaning that value of x doesn't satisfy the equation. So if you plug in that value of x in the original expression or equation, the left side would not be equal to the right side if that value of x is an extraneous, or if that solution is extraneous. Alright, so let's try. So that is 2 absolute value of 3 times 3 minus 2 equals 14. So this is 2 absolute value of 9 minus 2 is 7, right, equals 14. So this is 14 equals 14. Therefore, x is a solution. Then the other one is okay, then the other one is 2 times 3 times absolute value of 3 times negative 5 over 3 minus 2 equals 14. Let me just write that in blue. Okay, here. So this is 2. This cancels out. Absolute value of negative 5 minus 2 equals 14. 2 times the absolute value of negative 7, 14. Absolute value of negative 7 is 7. Then 7 times 2 is 14 equals 14. That means negative 5 over 3 is a solution. Alright. Okay, did it say... Oh, it doesn't say to graph, so we don't need to graph that. No questions on those two problems? You understood those well? Okay. Okay. You think so? All right. Okay, the next one, what's the question here? Just to solve for y? Okay, so we have here absolute value of y minus 5 minus 2 equals 10. All right, we isolate the absolute value first. We add 2 to both sides. Okay, so we'll be left with absolute value of y minus 5 equals 12. And again, we can split this into two cases since this is an absolute value. Okay, so we can write for case 1, this is y minus 5 equals 12. And for case 2, this is y minus 5 equals negative 12. Then we solve for y. We add 5 to both sides. Then y is equal to 17. Then here, the same. Then y is equal to 12 minus 5 is 7. Negative 7. Okay. Then, yes, because that is negative 12 plus 5. Then we check the solutions if they are real solutions to the original expression or equation. 7 is also a solution. Okay. All right, no questions on this. Can you please clear the board? Okay, in the next problem, solve each equation, check for extraneous solutions. So we're given here absolute value of 3x plus 5 equals 5x plus 2. Okay, so we solve for x here by simplifying both sides of the equation. So let's recall the property of absolute value. So if, say for example, let's say absolute value of a equals b, this can be a equals b or a equals negative b, two cases. Provided that b should be greater than or equal to 0. So in this case, a is 3x plus 5 and b is 5x plus 2. So we can do like this. Case 1, just write. So case 1 is 3x plus 5 equals 5x plus 2. Then case 2, that is 3x plus 5 equals negative 5x plus 2. Okay, then we solve for the value of x for both cases. So we subtract 5 here. This cancels out. So we're left with 3x equals 5x. 2 minus 5 is negative 3. Then we subtract 5x from both sides. We're left with 3x minus 5x is negative 2x equals negative 3. Then, can you still see me writing? We have negative 2x equals negative 3. We divide both sides by negative 2. So x is just equal to 3 halves. 3 halves or 1.5. Then the other one, the other case, this is 3x plus 5 equals, we distribute the negative sign, that is negative 5x minus 2. Then we subtract 5 from both sides, and we're left with 3x equals negative 5x minus 7. Then we add 5x to both sides, and this cancels out. 3x plus 5x is 8x equals negative 7. Then we divide both sides by 8. Therefore, x is equal to negative 7 over 8. We can check, we can now check if these values are really solutions to the equation. Alright, can I delete this one, this part here? It's okay. No, here I'm deleting only part of it, so we still have the values of x. Okay, so let's substitute each of these. So absolute value of 3 times 3 halves plus 5 equals 5 times 3 halves plus 2. So what is this? 9 over 2 plus 5. Absolute value of that is that one. This cancels out, so 3 plus 2 is 5. What is this? 9 over 2 plus 5. 2 divided by 1 is 2 times 5, 10. It's 19 over 2. For this case, trying to check on this. Oh, I think, did it say to check for extraneous solutions? It says right, the value of x that get the first value, this one is positive, and the second one is negative. The one that is greater than 0 is 3 halves. So 3 halves here is the solution. Because we have an absolute value here. It should be absolute value of 3x plus 5 should always be greater than or equal to 0 if it's an absolute value. Alright? So that means only this one is a solution to that one, is a valid solution to the equation. So this one is the extraneous. Okay, which one? Which one? It should be greater than or equal to this one. Okay, if we're going to plug in 3 halves there, so that is 5 times 3 halves plus 2. So I'm writing in yellow. It's on your end, but it says your internet is okay. Now, can you see me? See me writing here? Okay, so we're checking if b is greater than or equal to 0, because the absolute value 3x plus 5 should be greater or equal to 0. So when I plug in 3/2, everything is positive. So that means it's greater than 0. So x equals 3/2 is a solution to the given equation. But if I'm going to plug in negative 7/8 to 5x to b, the answer would be negative, right? This is negative 35/8 plus 2. What is that? Negative 35/8 plus 2. Yeah, so negative 7/8 is not a solution to the given equation. So there's only one valid solution here, which is 3/2. Can you please clear the board? Solve each inequality, graph the solution. So we're given here the absolute value of x plus 3 greater than 9. We're given here an absolute value, so it should be greater than or equal to 0. And it is greater than 9 is positive. So our interval notation or inequality form, we use or interval notation is union. Okay, so we do case 1. Case 1, x plus 3 is greater than 9. Then the other one, case 2, this one is x plus 3 less than negative 9. We switch that one because it's negative. Okay, because this is not equal. This is greater than and less than, inequality. So we solve for x. We subtract 3 from both sides. So x is greater than 6. Then the other one, we subtract 3 from both sides. So x is less than negative 12. So the answer here, interval notation, inequality form, is x is greater than, okay, x is less than negative 12, or x is greater than 6. Take note, if the given equation has an equality greater than, then your interval notation or inequality form, you use or. Alright? And the interval notation would be this one. It says x is less than negative 12. So all of the numbers less than negative 12, so that is from negative infinity, to negative 12. But negative 12 is not included. So it's open, union, greater than 6. So 6 not included, and all of the numbers greater than 8. So positive infinity. And if you're going to graph this, because we are asked to graph, right? Okay, if we're going to graph this on a number line, can you see my graph here at the bottom? Yeah, it'll just be here. So maybe yellow green. Can you see that? The graph? That one. Okay. It says negative 12 less than. Let's say this is 0. And this is negative 12. And this is 6. It says negative 12 less than negative 12. So all of the numbers, this is open. open. I'll just use another color. So it should be open because negative 12 is not included, and then to negative infinity. And then 6 should be open to positive infinity. So that's how you graph that. Okay, no questions on this. Okay, the next one, 3 times absolute value of 2x minus 1 greater than or equal to 21. All right. Okay, how do we solve this? The same thing. We isolate the absolute value first. We divide both sides by 3. So we're left with absolute value of 2x minus 1 greater than or equal to 21 over 3 is 7. Right? And then we apply the absolute value inequality, equality rule. So that means absolute value of 2x minus 1 is greater than or equal to 7, and the other one is less than or equal to negative 7. All right? To case 1. Case 1. So this is 2x minus 1 greater than or equal to 7. And the other case, this is 2x. It's 2x. It's 2x, right? 2, okay. 2x minus 1 less than or equal to negative 7. I think I am, because I mistakenly wrote 2x instead. Okay, now we solve for the value of x. Now we solve each case. We add 1 to both sides. So we have 2x greater than or equal to 8. Divide by 2. So x is greater than or equal to 4. Then the other case, we add 1 to both sides. We have 2x less than or equal to negative 6. Divide both sides by 2, so x is less than or equal to negative 3. Right? So our final answer here would be x x is less than or equal to negative 3, or x is greater than or equal to 4. Or in interval notation, that would be negative infinity, negative 3. 3 is included. So it should be a bracket, union, x is greater than or equal to 4. 4 is included, to positive infinity. You got that? Okay. No questions on this? Can you please clear the board? So we will be done with this one, the absolute value, and then we do, in our next lesson, we will do the other one, because that one is different. Well, what's the last question? What's the question here? What's the question for the last question?